Welcome to PosterCast. This is a demo of the PosterCast iPhone app. PosterCast offers a variety of security options. To access a private poster session, a unique badge number and last name must be entered by a registered user. Once the user has been authenticated, a list of posters is displayed. You can scroll through the list and give your favorites a star. In addition to scrolling, it is possible to find specific posters by searching for poster title, number, or author name as shown here. Posters can also be accessed by entering the poster number into the numeric keyboard, as shown here. Easiest, however, is to scan a poster's QR code using the built-in scanner. Pressing play lets users stream a 3-minute PosterCast highlighting key information on the poster. You can listen to a PosterCast like you would a phone call, or with headphones, or with your phone's external speaker. Here's an example PosterCast. International validation of a dithiothriotol, or DTT-based method for resolving the daratumumab interference with blood compatibility testing. This poster is presented by Richard Kaufman, MD, and colleagues. Daratumumab, or DARA, is a human monoclonal anti-CD38 antibody used to treat multiple myeloma. DARA interferes with routine blood compatibility tests by binding to reagent red cells. We developed a DTT-based method to eliminate the DARA interference, and we hypothesized that this method could be generalized for use by blood banks worldwide. We performed a send-around validation study to determine the proportion of blood banks that could identify an unknown alloantibody in the presence of DARA using the DTT method. Look at Figure 1, located in the bottom left-hand corner under Methods. This figure is entitled Antibody Challenge. Each of 25 participating blood banks was sent 2 unknown plasma samples. Sample 1, top, was spiked with DARA only. Sample 2, bottom, was spiked with DARA plus an unknown alloantibody. In Step 1, each lab was to perform an antibody screen using their preferred routine method. In Step 2, the antibody screen was repeated using DTT-treated red cells. In Step 3, labs tried to identify the unknown alloantibody using DTT-treated red cells. Look at Figure 2, located at the top of the middle column under Results. This figure is entitled Representative Antibody Screen with and without DTT. As shown in Panel A, top left, incubating untreated screening cells with plasma spiked with DARA only caused agglutination of all 3 cells. As shown below in Panel C, bottom left, pre-treating cells 1, 2, and 3 with DTT eliminated the DARA interference. Panel B, top right, shows that incubating untreated screening cells with DARA plus anti-Duffy results as expected with positive reactions in all 3 cells. However, in Panel D, bottom right, you can see that after treating the cells with DTT, only Duffy positive cells 1 and 2 show agglutination, while cell 3, which is Duffy negative, remains unagglutinated. Thus, the underlying reactivity of anti-Duffy remains easily detectable after DTT treatment has eliminated the DARA interference. Look at Table 1, located directly below the previous figure. This table is entitled Results of Antibody Challenge. This table summarizes the results of testing done at the 25 participating study sites. As shown by the middle column labeled DARA interference, all sites reported detecting the DARA interference using their routine antibody screening method. As shown by the next column, entitled Interference Eliminated, 24 sites observed elimination of the DARA interference using the DTT assay. As shown by the last column, entitled Antibody Identified, all 25 sites were able to use the DTT method to correctly identify the antibody unknown, either anti-Duffy, anti-D, or anti-s. In conclusion, using DTT-treated red cells, all participating blood bank laboratories were able to identify a clinically significant antibody initially masked by the presence of DARA. The DTT method can be implemented by blood banks globally to provide safe blood products to patients on DARA. Thank you.